You can tell which of us love to follow rules in school because we have our slides being 4x3, which is what we were told to do in the speaker notes, which I've noticed most people ignored, which worked out well for them. This talk is DevOps-Empowered Data Science with Ansible. Using the word DevOps was mostly a marketing ploy to get people here. But this is basically a talk for people who are working data scientists or doing something similar and who spend time working on probably like commodity machines on AWS or something similar where you get a remote server and you SSH into it, and the talk is particularly for those who then spend some time manually configuring it to have all their dependencies that they need so that they can run their code or do some research or something. If the idea of getting on a machine and then having to set it up the way you need it is foreign to you, thank your DevOps or other support staff that are helping you, and you can probably go see one of the other talks because you don't need this. But many of us are in a place where we're doing this ourselves, and my main argument here is that there is probably a better way to do it than the way that you do it or the way that I often do it. So what that looks like for me, I SSH into my EC2 machine. I'm very clever. I actually remember to update apt-get and then even upgrade the things that are already installed with apt on the machine. And then I think I might want to use Beautiful Soup to do some scraping or something, and I remember something about these LXML errors. So I go ahead and install Python LXML with apt. And then I go into my code directory that I somehow got on there with rsync or something. And then I go to create a virtual environment. And oh look, there's no module name virtual environment because Python 2 was what was installed on my machine. And I'm trying to use the Python 3 VM module. So I go back and apt-get install Python 3. And then, okay, I can finally create my virtual environment, and I can activate my virtual environment. I install the code that I have, and then I remember I made some changes, and I want to pull down the changes from Git, and so I do a Git pull. Oh wait, Git's not on my machine either. So then I go and apt-get install Git or yum install Git, and go through all of this, and then I'm working on a spot instance because my company wants us to save money, and all of a sudden my spot instance goes away. Then I go back in and set it all up again the next time manually. This is a bad way to work, but I think a lot of us do this quite regularly. And so I'm going to suggest if this is what you do and you're responsible for this yourself, Ansible is a good tool to use as an alternative. Ansible is in a class of tools that are used for what's called configuration management, which is if you're a DevOps person and you're insulted by my definition, it's fine. Just relax. I'm just trying to help people. But configuration management is effectively just trying to get the dependencies that you need on the systems that you're using. I like using these kinds of tools because they're efficient. Hopefully, in the long run, they're going to save you time. It might take more time to start, but it's also going to save you brain power as you automate these things. They're reusable. You can take components and use them in multiple configurations. They're scalable in that you can configure multiple systems at once. You can even test these things by testing your configurations to see that they have the dependencies you need if you're automating deployments. They're self-documenting, at least in the sense that the commands or the things that you need on your system are documented in these effectively code or config, like YAML files in the case of Ansible, versus your system configuration being half documented in your head and half in your bash history, like a lot of us do. They're versionable in that you're representing the configuration of the system as text files, and you can then put them in your repository, and they're reproducible in that you can, a stranger could even potentially configure an environment, even if that stranger is you in 4 months when you're coming back to the same project. So Ansible is one of several. If any of these ring a bell, they're all roughly doing the same thing. There are a lot of different nuances between them, but Ansible, SaltStack, Chef, and Puppet. I'm proposing Ansible as a solution for many of us because you can get started using it today. Ansible is effectively a Python program that turns this YAML-based DSL into shell commands that it runs over SSH to configure your machine. So all you need to get started is to be able to pip install Ansible and have SSH access to whatever machine that you're trying to configure. So here's how you get started: pip install Ansible. And Ansible gives you a command line tool called Ansible that allows you to run things on your machine. So you're running it locally, and it's executing it on your remote machines and showing you the results. Here this is an example of running something locally and seeing the result locally, but just as a kind of a hello world, it has a ping module to see if you can access the machine you're trying to access. So I'm basically trying to say, can you access my own machine that I'm running this on? And it's going to return back to me this result saying success. So from there, I'm going to set up an Ansible inventory file, which is essentially just a list of the systems I want to have access to. These Debian, Amazon, Ubuntu are just IP addresses for Amazon light sale machines that I have set up in my SSH config, and these are the default names from Amazon. And I'm putting them in a file called hosts, which Ansible can read it's called an inventory file. It's the machines I want to actually configure. If I have time at the end here, we can run something for real on these machines that I spun up. And so now I could execute this ping command on my local computer, and Ansible is going to go out, and ping is basically saying, do I have SSH access to these machines? And from there, we can go and do things we want. Well, that's all cool, but the whole point of this is trying to get away from configuring our systems with command line commands. Sorry, I've got one slide ahead of myself. Just pinging is interesting. We also want to be able to do more interesting things. So Ansible has what are called modules, which are special functionality that allow us to do a bunch of different tasks. So for example, there's a module called package, which is going to go onto the machines and attempt to install some packages. So what I'm saying here is use the package module. I'm going to become the root user, because a lot of package managers you would have to run with sudo and be the root user. And what Ansible is saying is ensure that htop is present on the machines, and it's going to run it on all the hosts in my inventory. So those were the 3 machines that I listed. So again, doing this all from the command line is great, but what we really want is to put this into files that we can make more complex, save in our version control, and use in the future, and not have to rely on remembering the commands that we typed in at the command line. So that exact same command that I just put in the command line, I can put in what Ansible calls a playbook, which is a YAML file representing that command, and actually the ping command also. So this is first going to ping all my systems, and then it's going to ensure. It says state absent. It should actually stay state present. It's going to ensure that htop is present on all my systems. And I'm saving this as a playbook called SciPy play.yaml. And I can run that with the Ansible playbook command line command, and it's going to go onto each of those machines, ping them, and then make sure that htop is installed. And one of the things, if you're particularly observant and up to date with the nuances of Linux distributions, you might note that the Amazon EC2 instance, the Amazon Linux AMI is going to use the yum package manager. These other 2 are going to use apt-get. The package module in Ansible is attempting to abstract that away, and it's going to decide underneath what to do to install those packages. I don't necessarily have to know. If you're lucky, there are some ways that can fail. We can do more complex things like add loops into our YAML file. So these are like Jinja templated YAML files. So I can define a variable called programs and give it a list of programs I want to make sure are installed, htop, git, and tmux. And instead of just installing one program in my playbook, I can tell it to loop over this variable I defined called programs and install each of those programs. So I could execute that. From my local machine, Ansible is going to convert that into into shell commands and then behind the scenes SSH into my 3 boxes, and then make sure those things are installed. I keep saying make sure they're installed versus install because Ansible and other configuration management tools are based more around the idea of declaring the state that you want your system to be in versus telling your system what to do. So I'm not thinking about it so much as tell the system to install this thing, but saying to Ansible, ensure that this thing is installed on the system. So if it's already there, you don't need to install it again, is the bottom line. And it attempts to make things as idempotent as possible so that you can run it multiple times and your system stays in this state that you desire. And so running it twice isn't going to mess things up for you. So there are a bunch of built-in modules, things that Ansible can do without you having to tell it how to do the things. You can just declare what you want to be done. You can pull things from Git, you can post to Slack, you can schedule cron jobs, copy files between the systems, manage S3 objects, create a user on the remote system, add a public key to the authorized users for SSH, run shell commands if you want to just do arbitrary things. You could send an event to Datadog. You can tell it to run makefile targets on the remote computer. And there are a bunch of other things from the fairly low level to as high level things as sending things to Slack. If you want to do more specific things that are customized to what you want to do, you can actually define your own Ansible modules, which are, you can like write your own Python code or actually in any language to define your own modules, but you can also make combinations of the modules that are already there in something called roles. So a role is a number of different tasks and the variables and configurations around that task that you want to execute. And then the big selling point here is in that role becomes reusable in multiple playbooks. So maybe you want to do the same sort of actions in different systems or for different projects, you can reuse the same role. So the example that we have here is a role that is going to install mini Conda, and a role is defined by using the folder layout as part of the definition, the syntax, which was a hard thing for me to get my head around originally. So this is just looking at the file structure and a folder called mini Conda, and then these subfolders, and then YAML files within the subfolders. And the folder names matter and the organization matter in the way that YAML is defined. So it has a README where we can put instructions or other information you need to know. A folder called defaults, which are basically variables in the role that are configurable, and we'll see that in a second. The tasks, which are similar to these playbooks, they're just lists of the commands that we need to execute. So these are going to be the commands that actually install mini Conda. And then there are tests that we can define to test that the role is doing what we want it to do. And then there's something called vars, which is similar to the defaults, but the vars are, you can essentially think about them as like variables that we want to abstract out of the tasks files, but they're not something that we're going to configure when we actually use it. So here's a use of this SciPy role. This is another playbook, which is a mapping. You can think of a mapping, a playbook as a mapping between the servers we want to work on. And here's my group. I don't think I actually explained that, but in my inventory file, I called these 3 computers the SciPy group. And then I'm going to say on those hosts, the SciPy hosts, execute these roles, and the only role I have is my mini Conda role. And then below that is some of the variables that I want to configure. So I'm telling the role to install mini Conda with Python 3 by default, update Conda when you install it, which is like Conda update Conda, and then create a Conda environment called SciPy and install SciPy 1.1.0 on there. So I could then execute that in the same way that we had been executing playbooks before, Ansible playbook, and then execute whatever that file was called. So Ansible, which is maintained and supported by Red Hat, has a tool called Ansible Galaxy, which is like a big repository for roles. So this mini Conda role is actually one that's someone has written and published as a GitHub repo, and then it's published through Ansible Galaxy, and they have a CLI that you can actually download these roles to do certain things to your local system. You could install what we just saw with Ansible Galaxy, install mini Conda, and it's going to pull down this role and let you use it. One thing to note that you do have to be aware of is you're essentially downloading these, they're YAML files, but they're executing arbitrary commands on these remote machines. So you do have to be aware of the security implications of using things like this. You can't just download something blindly and then use it. You really have to look into what you're using. And it's a very powerful way to get tools like this without going through all the setup yourself. This is a big, long conclusion slide, but the idea here is to give you some framework for this is a high-level view of how you use Ansible and what it can be used for in your data science work. You can install Ansible with pip. You can set up your inventory file with the machines you want to control. You can write roles to encapsulate the tasks, variables, and relevant files to do a particular job. You can use Ansible Galaxy to reuse pre-built roles, and you can write playbooks to connect your tasks, including your roles. So task and role sort of become the same thing. You're encapsulating multiple tasks in a role, and it becomes like a single task. And you can put those, you can map those to your inventory that you want to run. And then you can run your playbooks to configure your systems. And the best of all, in all of this, is that you can document and track the changes to your systems. If you don't start just going in and making ad hoc changes, you can track those in your configuration, in your version control system like Git. So I want to show some examples, and then I'll have some time for questions. Live typing is not my greatest skill. So we can run this Ansible module ping, and we can tell it to ping all, and it's going to ping these systems that I have on AWS. So this is real live, internet's working, communicating with AWS. These are defined in my SSH config with these names. So pinging isn't that interesting. You saw my it's trying to autocomplete, but you can actually tell ping, instead of replying with Pong, reply with some arbitrary string, and it replied with hello SciPy. I tried telling it to reply with the snake emoji, and it really messed up my terminal when it replied. I had to completely close it all and restart it. This is Python 3 too, so it should work. But this is only of limited value, but if you tell Ansible to run 3 levels of verbose, it can show you what's going on underneath. And this is very hard, it's challenging to read, but it's enlightening in that you can see that what is happening underneath is Ansible is converting these commands that I'm telling it into these SSH commands, which are running on my remote machine. So these are all these different SSH flags. And that's all fine, but then what it's actually doing is executing this Python script called ping on the remote machines, and it's getting the output of that and returning it to my system. So all of this is just a YAML DSL around SSH and shell commands. There's nothing fancy going on here, but it allows you to abstract away a lot of complexity that you would have to do otherwise. Right, so we also had written this role, which is install mini Conda, And it looks like this. So I'm telling it on the SciPy hosts, and I could also put all there since my only hosts that I defined are SciPy, and you can see that in my hosts file. These are the machines that I'm accessing. On all the SciPy hosts, I want to execute this role, and the role is called miniconda, and what that's going to do is install miniconda. But I'm not telling it how to install miniconda, I'm just declaring to it, ensure that miniconda is installed on this system. So we can run this live. I ran this live, or ran it on one of the machines to test, but I haven't actually run it on the other two, so we can see if it will successfully run. This is very exciting. So it's saying it already found it on the Debian machine, so it's not going to try to install it again on the Debian machine. And each of these tasks is a component of the miniconda role that I've downloaded. So the role is composed of a whole sequence of tasks that it's executing on my machines. This is the last thing in the talk, so I will go ahead and start taking questions as we watch the Conda installer download.
All right, first question.
Hi, thanks for the hands-on talk. Can you clarify something for me? Because with everything being named SciPy, I'm getting confused because this is this conference, the package, your host, and you had a slide that said installing miniconda with SciPy. And what are we talking about here? Because I normally install SciPy with miniconda. Thank you.
Yeah, that is confusing. This conference is SciPy. I named my group of machines SciPy, and then I also named my Conda environment SciPy. But that was just an ambiguous preposition. I installed miniconda, and then I used miniconda to install the SciPy library. Yeah, installing miniconda with SciPy, meaning using miniconda to install SciPy, not the other way around. But
So it should be installing SciPy with miniconda.
Yeah, that's exactly.
So I know that Ansible has a lot of flexibility in the way that you can structure the YAML and all of the. Where do you think are the best practices for that so that you don't end up with a huge ball of code?
Yeah, so I'm not really the best person to answer that question. Ansible ends up, as you start to use it, it ends up being incredibly flexible. In many ways, it forces you to have structure, but at the same time, you could do something like put everything you want to do all into one big playbook, and then it ends up becoming just unwieldy, and then you can start to define roles, and where you define variables and various things can get quite confusing. I would recommend, first, the Ansible documentation is actually very good. I've read through, I just sat down at one point last year and just read through the documentation, and it's very readable. And they particularly have a section in there called Ansible Best Practices where they talk about some of those things. I think that would be the best place to start in looking at that. This thing completed, so we can actually look at one of our machines. So the Debian one already had miniconda, but we can look at this Amazon machine. There we go. This is the real deal, no tricks here. And we see that miniconda is present here. It didn't put it on my path, but I can say, I actually haven't been using Conda for the last 9 months, so maybe I can remember the commands, but right? So there's SciPy on my EC2 machine that that installed while we were watching. And you can take this exact same thing, go use this, even if you get that far in automating the system, the things that you use. I think it's a great step over alternatives. Alternatives being doing it all manually every time.
Yeah, so I don't know if you know the answer to this, but when it was showing the verbose commands, at the end of each one it said like sleep 0. I'm curious why they do that.
I have no idea, Aaron, but you are the perfect person to go find that out and let me know. That's a great question.
Okay. Oh, yep.
Sure. Hello. Hi, I'm Andrew from Wharton. We use this, it's amazing. We just switched. We were doing everything pretty manually before then. I just want to comment real quick that the fact that you can use an agentless client, you don't have to install anything into your clients, made this so much easier for us to implement and move to. So that was a big deal for us. Yeah. And this saves so much time. Thank you.
Yeah, so a lot of the other tools, if you use Chef, Salt, Puppet, require an agent to be running potentially on the client, and then you also have like a master that's interacting with them, and getting started with it is quite hard. A lot harder than using Ansible. That's a big part of why I promote Ansible.
We've got time for another 2 quick questions.
Have you ever tried to use Ansible for something like scheduling? I mean, I see how you maybe set up your environment with it, but if you wanted to, almost like a mini Airflow kind of thing, can you like do task scheduling with it, or would that be an abuse of this?
I don't know of great ways necessarily to do that. The one thing I will say that I've found to be quite effective is Ansible allows you to control cron jobs on a machine, and it's going to edit the cron tab for you. And I've found that manually editing the cron tab file just ends up always being a disaster. And you can specify your cron jobs in these YAML files, and then tell it, go set up cron according to this configuration, and install dependencies and various things. That's worked out really well for me on one thing I can remember. The biggest challenge was sometimes you end up like having to escape quotes on like so many levels that you have like these really weird triple quotes, and half of them are escaped and all this different stuff. But yeah, if anyone else has more knowledge of that, it would be interesting to know.
Yeah, just another +1 for Ansible. It's amazing for provisioning and deployment. But my question to you is more also like along the lines of best practices. Do you keep all your playbooks in one repo, and then during your automated deployments, like check out that repo and pull out the playbooks you want, or do you keep the playbooks with the code that you're deploying?
Yeah, again, I don't claim to be an expert on best practices. I would just keep them with the code. I think that works well if you're kind of managing this yourself. If you have a person or team who are more responsible for this more kind of ops type stuff, it might make sense to have a bigger repo with all your different configs. But I've found in the things that I do, I mean, it becomes similar to having your requirements.txt file or your Conda environment file. These are just the broader dependencies that you need for to run some code, and keeping it all in the same place works well. But
we thank the speaker again.